So 10.3 is called Composite Functions. We've talked about adding and subtracting functions, that's sum and difference. We've talked about multiplication and division of functions. We're going to talk today about composite functions. Now, composite functions are very, very important for calculus. We talk about a function within another function. We talk about that a lot in calculus. It is a huge part of finding derivatives and finding integrals, which at this point you know nothing about. But when we do that, recognizing that there is a function within another function is very important. So when you think of composite, think of composition. Okay, we're putting things together. There's something inside of something else. A function within another function is helpful to remember. And a third sort of good thing to write down and to remember to help you with composite functions, you can think of it as a function in terms of another function. So if we consider that, if we have a function f of x, okay, what this means is that this is really a function in terms of x. So x is the variable, right? It is explicit in that f of x, which is also called y, equals some sort of mathematical description with only the variable x in it. It's explicitly described in terms of x. This section is something like this. You can have a function f, but instead of being described by x only, it can actually be described using another function. So this looks a little odd, but this is f of x up here. This is f of g of x. It's literally, you literally say it f of g of x. There's different ways that we can say that. I'll tell you a little bit more about that later. But this is a function within another function. See? G of x is inside the larger function f of x. And I know this is something new, but this is what we're looking at. So this is a function, and that is really, it's, you know, f of x in terms of another function, and that function is g of x. Okay? So that's kind of the big picture of composite functions. We're going to be working with this. We're going to be recognizing separate functions. So we're going to be recognizing a larger function f of x, and inside what we could call a separate or a different function g of x. Okay? On page 499 we have an investigate composition functions. And so this is how it's set up here. It says consider the function f of x equals 2x, and the function g of x equals x squared plus 2. The output values of a function can become the input values for another function. Okay? So remember we said f of g of x, right? And so whatever g of x is, we put x into the g of x function, and whatever that value is, we then put it into the f of x function. That's what this means. So the output of the g of x becomes the input of the f of x. And here's a little bit of a diagram to help you understand that. If we take an x value here, okay, of 2, and I put it into the function x, what do I get? 2 times 2 is 4. Now, that is the output of function f. Now I'm going to turn around and I'm going to put that into g. So I go over here and I say, okay, if this is now 4, and I put it into the g machine here, 4 squared is 16 plus 2 is 18. Right? So I put 2 into f, kicked out 4. I put 4 into g, and it kicked out 18. That is this right here. Put x into g, then put the g of x into the f of x. So yes, in this example, this was the example that we used. For this one here, it's actually like this. It's g of, and then f of x. Thank you. Yeah, that is true. This was our example, and So they've got f here, so x goes into the f function first, and then that output goes into the g. So yes, it's f first. That's the inside function here. So the question is, if we were to fill out a couple more of these, here we have all the values, and the question is, down here, number 2, the question is, how do I get from x over here to this final y value over here? Which one of these equations would represent this as x and then this as h of x? So take a moment just to look at each one of these functions, test some points, put x into a function, and then find out what the value is at the end and see which function represents this. So take a minute to look at that. Okay, so D was suggested. So what did you do? You put in a value for x into here, and you want to find out if it matches this output value, right? So if we put in 2 there, that's 2 squared is 4, times 4 is 16, plus 2, 18. Good, that one works. Let's try 0. 0 should yield us 2. Well, 4 times 0 squared is 0, plus 2 is 2. So it looks like this is it, and indeed D is it. Okay? And I want to show you something, that this D is the answer we're looking for, but this can also be written, okay? Now this may seem obvious to you, but it may not. This can also be written here. 4x squared is actually 2x all squared plus 2. Okay? 2x all squared plus 2. And I want you to notice, and this is the tricky part, okay, but this is the most important, that this larger function right here is something squared plus 2. Do you see how it's right here? Something squared plus 2, that's the larger outside function. And what's inside of it? What is inside of it, that is what goes in the variable spot here, but this function right here. So you see how f of x has been put inside of g of x here? This is f of x, and this is g of x. It's kind of like substitution. Yes, exactly. Yeah, it's kind of like substitution. We are subbing one function in for the variable of the other function. Yes, that's a perfect way of thinking about it. Composition, substitution. Yes. Any other thoughts? Okay, so a function within a function. Awesome. So let's back to your textbook here, and it talks about on page 500, composite functions. So let's just read along here, and you can write down some jot notes if you want in your notebook, or just follow along here. But it's basically explaining exactly what we've kind of come across here. It says this: composite functions are functions formed from two functions, f of x and g of x, in which the output of one is the input for the other. For example, if f of x is the square root of x and g of x is 2x minus 3, then the composition of f of x and g of x, that is this right here, means that the g of x function, that's this, goes inside the f of x function. So if f of x is square root of x, I want to put g of x inside there, and that's how you get the square root of g of x, the square root of 2x minus 3. That is the composition. So here is f of g of x, okay, is the g of x function, which is this, goes inside the f of x function to yield you that. Now, the other note here is when composing functions, which is sort of the verb here, the composing of functions, the order is important. So this right here, f of g of x, is not necessarily the same as g of f of x. Okay? So if you can't just, if you put one inside the other, it's going to be the same as if you put the other inside the one, right? Go backwards. It doesn't work that way. Sometimes it would, depends on the functions, but most of the time it doesn't work, so it's not a rule. And yeah, g of x goes inside f of x. Okay, let's get some, well, actually, before we get some practice here, let me talk about some notation. Okay? Most of this we just talked about, okay, substituting one into the other. Here's an important note. This composition, okay, of functions exists only where, only for the x values that are in the domain of g, okay, for which the g of x is also in the domain of f. So you can't have any restricted values, then it breaks down, right? If you have something that's undefined, you can't put an undefined value into another function and expect an answer. That's pretty obvious. Here's the other thing too. As I mentioned, this is f of g of x, or f composed with g. This notation is also important, which you will see. F, and it used to be in other textbooks even, they used to say you can call this f circle g. Okay, instead of saying composed with g, you can say f circle g. I'm not sure if anybody does that anymore, but you might hear that. So this is a composition. It's very different, does not equal this. Remember, we did this the other day, f times g, right? Those are very, very different, not multiplying. It's one inside the other. And I think that's what it's saying down here, okay? So it's not to be confused with multiplication. All right, so let's do some examples. Okay, so if f of x is 4x, and g of x is x plus 6, and h of x is x squared. Okay, we have those three functions. Let's do a little test here and see if you know what you're doing. So let's do this, f of g of x. And I want you to write that down as a, it doesn't even have to be simplified really, an unsimplified equation. Okay, so take a moment and just take a moment and write that down, and I'll reveal the answer in a second. Okay, so an unsimplified resultant function should look like this. G of x, which is this one right here, goes inside f of x function. See, g of x inside f of x. And so wherever you see the x value of f of x, that's where you put g of x. So 4 times x plus 6. Okay, it does not just mean, no, it doesn't just mean multiply. For this one, it does, because 4 is multiplied by x here, right? And so when you substitute another function into here, the result is multiplication, yeah. But composition doesn't mean multiplication. In this case, you are multiplying 4 times the other function. Yeah. Yeah, we're just substituting, exactly. Instead of f of x, it's f of g of x. So instead of 4x, it's 4 times x plus 6. Yeah, substitution. Okay, good. Let's do another one. Let's do g of h of x. Okay, why don't you try that one now? G of h of x. Okay, so we take h of x, which is over there, x squared, and we put it inside of g of x. So this, right here, goes inside g of x. See that? And here's your result. Now, I left the brackets there just so you could see that this x squared is in place of this x. Okay? Any questions about that? All right, let's do one more. What about this? h of x. Ooh. Doesn't even need to be another function. You can put a function inside of itself. So let's see if you can do that. Okay, I'm going to explain this one this way. I'm going to write down h of x really kind of twice here. And what you have to do is to put the h of x function, which is this in yellow, inside what? Well, the h of x function, which happens to be itself. So you need to put an x squared in for where x goes. So you end up having x squared squared. So it's inside of itself, simplified to x to the 4th.